Hi guys. I know this isn't ideal, but my daughter's sick, and so I have to be home with her. Hopefully, I can talk through the review with you and help answer any questions that might be bothering you. The first 5 problems, is about just what would the scatter plot look like if given certain correlation coefficient values. And what we want to remember is that values closer to a -1 or +1 are going to be more linear, more tightly bunched in a line. Values closer to 0 will be more scattered. And then negative values will be trending down from left to right, and positive values will be trending up from left to right. So first thing I would look at is this -1, +1. We see that number 1 here is definitely pretty tightly packed and is trending down, so that would be my -1 R value. And then if we look at the number 5, we see that those are pretty tightly packed and almost like a line and trending up, so that'd be my +1 value. And then look at what's left. If you look between the 3 that are left, notice that number 2 is very scattered. Doesn't really seem any up or down pattern to that, so that'd be my 0 R value. And then noticing that the number 3 tend to go up and number 4 tend to go down, but are more loosely packed, so that's why they're not the ones. So that'd be the 0.5 and -0.5. Okay. So then we move on to the operations and compositions. Main thing we want to look at is what we're being asked to do. Make sure you're really reading that notation. So here we're being asked to add function g and function f together without plugging any numbers in. So I just want to take function f and function g and add them. So 3x minus 5, and being asked to add to that 4 minus 2x. So this is not a multiplication problem. Okay, so not multiplying here. There's nothing to distribute in front of the orange parentheses. There's also nothing but a +1 here in front of the blue parentheses. So parentheses aren't doing anything. So all I really need to do is combine like terms. So 3 minus 2x would be 1x, and then -5 plus 4 would be 1, or -1. So, and then remember, we want you to write the answers with the notation on them. So f plus g of x equals x minus 1. And then number 7 here, we have this open circle operator, which represents the composition. So we're taking g of f. And what I like to think about that is that means I'm taking whatever I get here, and I'm plugging that into g. So I'm going to do this first. So f of -1, figure out what that's equal to. So that's 3 times -1 minus 5. So that'd be -3 minus 5, which is -8. And we take that answer and we plug it into g. So that answer goes into g. So g of -8. So that'd be 4 minus 2 times -8. So it helps, kind of drag that number down there. So -2 times -8 is +16. So 4 plus 16, so that'd be 20. So writing the answer in the notation, g of, f of -1 equals 20. Alright, next one. So it's a similar problem with that open circle operator. So we're going to take h of g, which means we're going to take g and plug it into h. Now here we don't have a value, so that means we're just going to use the functions. So I'm going to be taking function g, and plugging it in to function h. That's going to go into here, or this way. Into there. So that x is going to be replaced by all of this. So what that's going to look like is 4 minus 2x going into place, so then plus 1. Again, there's nothing here in front of the parentheses to distribute, so they basically just go away, and I just combine my like terms, so the 4 and the 1. So this would equal negative 2x plus 5. Generally, you just want to put that x in front, but not a big deal if you don't do that right now, but it is a habit you want to get into. So if you wrote 5 minus 2x, it would also be fine. Okay, so the next one, so I'm going to make sure you're reading it. This is f times g. So it's different than the open circle. It's different than number 6 where it was an addition problem. So f times g, so I'm going to take f and g and multiply them together. So f was 3x minus 5, and multiply that by 4 minus 2x. Okay. And so a multiplication here is a distribution problem. So I'm going to distribute the 3x to the 4 and the 2x. So 3x times 4 is 12x. 3x times negative 2x would be negative 6x squared. And then I'm going to distribute the negative 5 to 4. So negative 5 times 4 is negative 20. And negative 5 times negative 2x is positive 10x. And now I have some like terms to combine, 12x and 10x. So I'm going to go ahead and write my notation, f times g of x equals, so my largest or highest term here, the highest degree term, which is something we haven't talked about yet, but it is the x squared, so I'm going to write that first. So that's the negative 6x squared. The 12x and the 10x can be 22x's, and then the minus 20. So there's f times g of x. Alright, g times h of negative 2. So with these problems with the numbers in them, with operations, what I would really suggest you guys do is rewrite it. So this is equal to g of negative 2 times h of negative 2. And that way you say, okay, what's g of negative 2? That's 4 minus 2 times negative 2, which is 4 plus 4, so that'd be 8. And then h of negative 2 would be negative 2 plus 1, which of course is negative 1. And multiply, so g h of negative 2 equals negative 8. So when you do multiply those together, you get negative 8. Pretty similar type process for doing a problem like number 15, where it says g of 3 minus f of 5. So g of 3, 4 minus 2x. So 4 minus 2 times 3 minus an f of 5, 3x minus 5. So that's 3 times 5 minus 5. Kind of put these in parentheses. Do that first. So 4 minus 6 is negative 2. Minus 3 times 5 is 15. 15 minus 5 is 10. So g of 3 minus f of 5 equals negative 2 minus 10 is negative 12. There you go. So just notice how we do each part and get an answer, and then do that operation with the two answers. And that's the final answer. Alright, number 11, pretty similar to number 8. We're going to take g and we're going to plug it into f. So I'm going to take whatever function g is, plug it into a function f. So where that's going to go is in the x spot here. So 4 minus 2x is going to go into this x spot up here. So I'd start with 3 parentheses, that's going to take the place, and then minus 5. And what's taking the place of my x is now 4 minus 2x. what you want to again make note of is that that original x that was with the 3 is gone. So there's not like a 3x here. It's a pretty common mistake, so be careful about that. Of course, we got a little bit of distribution there we need to do. That would give me 12 minus 6x minus 5. Combine like terms. So f of g of x. I'm going to put the x first, that'd be negative 6x. 12 minus 5 is 7. So it's 6x plus 7. Alright. Next one, f of h of 5. So again, what I want to start with is that back end of that. I want to figure out what h of 5 is. So h being x plus 1, so 5 plus 1, which of course is 6. And then we're going to figure out what f of 6 is. So 3 times 6 minus 5. Let's go 3 times 6 is 18, minus 5 is 13. So f of h of 5 is 13. 13 is pretty similar to 9, so I'm going to take f and I'm going to multiply it to h, f being 3x minus 5 and h being x plus 1. So there's some distribution here. So 3x times x is 3x squared. 3x times 1 is 3x. Negative 5 times x, negative 5x, and negative 5 times 1, negative 5. Combine those like terms. So f times h of x equals 3x squared. That gives me negative 2x's minus 5. Alright, last one of these. H minus g. So I'm going to take the function h, which was x plus 1, and I'm going to subtract function g, which was 4 minus 2x. So this idea of not just in front of the, we're not multiplying these two things together, we're subtracting them. So in front of the purple parentheses, there's there's a positive 1 to distribute, but in front of the green parentheses, there's a negative 1 to distribute. So if we think about it that way, this would become x plus 1 minus 4 plus 2x now. Combine like terms. So h minus g of x. So my x's would be x plus 2x would be 3x. And then 1 minus 4 would be negative 3. Alright, there's that first page done. Okay, so domain range can be a little tricky. So what I want to think of again with that domain range is domain is your leftist point to the rightest. So I look at that leftist side of the graph. So as I approach from the left, where's the first place I hit? It looks like negative 5 is that leftist point, and then as we keep going to the right, what's the rightest point? Looks like 8 is the other end of that. And so there's values between negative 5 and 8. So how do we say that? We say that use our curly brace, all x's such that's our x bar. Then we're going to use a compound inequality, so negative 5, and then space x space 8. And close out the curly brace, and then what goes between the spaces, so we just open up towards the right on both of those. And then as we look at the dots, so the negative 5 is a closed dot, the 8 is an open dot. Those closed dots get the line underneath, that's equal to, whereas the 8 will not get a line because it's not, because it stops right at 7.99999. So So all the numbers between -5 and 8, but not including 8. The range, then we want to think lowest to highest. So leftist, rightist, lowest to highest. So what's my lowest point on the graph? So I look at that, and it's here at -4. What's my highest point on the graph? It's right here. It's like +5. I would notice both of those are closed dots. It's not -5, +5. Both of those are closed dots. Both of these are going to get equals to. So this is range. So we're talking about y values. So all y's such that. So my lowest was -4. It's going to open to the right. Again, equal to because it's a closed dot. Make sure you put a y here. Open to the right again. Equal to because it was a closed dot. And the value was 5. So our y values are between -4 and 5. All those numbers in between there. F of 2. And the idea here is that the 2 is taking place of where the x would be. So I want to go to where x is equal to 2 and figure out what the y value is. This is saying if x was 2, what's the y value? So our answer here should be the y value. So at that point, that's 2, -1. So the y value being -1. This next question is kind of the reverse of that. It's saying, what's x if y is 1? So I want to go where y is 1. I want to get any x value that has that y answer. So if you look at that line there, all those points where it's crossing. So all these x's like -3, 1, 1, 1. This would be 4, 1. So any x value where the answer is 1 is going to be our part answer. So curly brace, since we have multiple answers, so we -3, 1, and 4 would be the answers. Those are the x's that have an output of 1. Alright, and then I have a lot going on here. Let me erase some of this stuff. Okay, so last piece here, so f of -1, so again that's my x value. So I look up, when x is -1, y is 5. We're going to add that to, what's f of 2? So when x is 2, y is 1. So 2 plus 1, of course, is 6. So just equal 6. Right, below that, so when is f of x equal to g of x? Remember, this is an x question. So these are, when is the y value of f equal to the y value of g? And that's so what x value makes these equal. So we're looking for that point where they cross, just the x value there. The idea is that if we plug 5 into both, we get the same answer. So you just say x equals 5. Okay, so the x value of the intersection point. What's f of -3? So let's look here. So where's x -3? Make sure you're looking at f, so this point, not down here. So when we plug -3 into f, we get 1 is the answer. Sorry, -1. Let's see, how'd you guys change this one? Let's see. If g of x equals -7, find x, right? That's what it said. So when g, so that's this line, when the y value is -7, what's x equal to? So we're looking at that point. So that means that x, means that x would equal -1. So when we plug in -1 into g, we would get -7 as the answer. All right. So I need to find the equation of both lines in slope-intercept form. Oops, that's not what I want to do. So first I'll start off with f, which I'm just going to highlight, which is this line. So we need 2 points, so we got those 2 points there. So I'm going to use my slope formula. So m equals y2 minus y1 over x2 minus x1, which is -3 minus -1 over 5 minus -3. So that's -2 over 8, which is equal to -1/4, or 1 over 4. And then I'm going to use point slope, y minus y1 equals m times x minus x1 to figure out what my y-intercept is. So the main reason I'm not going to use the graph here is because that intercept is set up weird decimal. I don't really know what it is, so I need to use this formula to do that. I can use either point, it doesn't matter which point I use to grab for my x1 and my y1. So y, so I'll use this point. So minus, my y value is -1, equals the slope, which was -1 over 4, times x minus, and my x value is -3. Of course, here we have pluses. We do the distribution of the -1/4, so we get y plus 1 equals -1/4 x, and then -1/4 times 3. Okay, guys, 3 over 1 would just be -3/4. Okay. Then we need to subtract 1 from both sides. So y equals -1/4 x. I'm going to come over here and do that subtraction, so the -3/4 minus 1. Well, 1 is equal to 4/4. So -3 minus 4 is -7/4. So that's my y-intercept, so minus 7/4. So 7/4 is almost 2, so almost -2. So we should kind of check our picture to see if that's right. We see our y-intercept is between -1 and -2. It's getting closer to -2. So it does make sense that, right, we go back and compare your picture. That's a good way to check to see if you got a good answer or not, if your answer is just junk. Okay, next one. So we use the other line now. So looking at line G, need the slope, so I'm going to use 2 points. Same thing, or we could do a different way, right? Count rise over run. So if I look between those 2 points, I have to rise 4, and then I have to run 6. So m equals rise over run, so 4 over 6 should be 2/3. Again, I could look at my y-intercept and it's not right on a line, so I can't just look at the graph. So I need to use the point slope again. So y minus, again, I get to pick which point, so I'll use this point. It doesn't matter which one you use. So y minus, my y value is -7 equals, got a slope of 2/3, x minus, or x value is -1. Again, we get some double negatives, those are pluses, so this gives me y plus 7 equals, then we go and distribute, so it'll be 2/3 x plus 2/3 minus 7 minus 7. So y equals 2/3 x. So a different way to think about it. So 2/3 minus 7 is similar to 7 minus 2/3. It's just going to be the opposite sign. So 7 minus 2/3, well, 7 minus 1 would be 6. This is less than, we're not constructing a whole. So if I take 2/3 away from something, I would end up with 1/3 less. So, or 1/3 left. So this would be 6 1/3. I'm not a big fan of, so that means that this is negative 6 1/3. Not a big fan of mixed numbers, but it keeps us from having to do some of that fraction work. And if we go back and look at our picture to see if it makes sense, where is it crossing the y-axis? So we see that it is between -6 and -7. It's closer to -6, which would match what we're saying here with 6 1/3. So, okay. Alright, so these applications of compositions, pretty tricky problems. So we've got a plan for a cell phone that's saying that the cost is a function of how many gigabytes of data we use. So that, and then we have another function that's telling us that the amount of gigs that we use is based on how much time we spend on using that data. And then wants us to find C of G of T. So basically what it's saying is it wants us to put G of T into here. Right, we're going to place that G with this, the 0.05 T. So C of G of T equals 20 plus 6, replacing with 0.05 T. So we need to multiply this 6 into there. So it's going to give me 20 plus, so 0.05 times 6. It's 0.3, so 0.3 T. So there's our new function. And it says find C of G of 60. So I'm going to take that new function, C of G of 60 equals, and so 20 plus 0.3 times, we're plugging something in, which is the 60. So 0.3 times 60 is 18. So I got 20 plus 18, which of course is 38. So C of G of 60 equals 38. So what does that mean? All right, the next thing it asks us to do is explain what this value means. So what did we plug in? All right, we plugged in 60. Well, 60 what? What did that take the place of? Okay, so that must be 60 hours. And what do we get out? Right, then the outside letter tells us what we're getting out. So 38. What did C have to do with? That was cost. So this is $38. So how could we explain what's going on here? Right, we're talking about how much money it's costing us if we use so many gigs. How many gigs we use if we're on our phone for so long. So if we're on our phone for 60 hours, our plan would cost us $38. Page 2 done. T. Oops. Finding inverse. Remember, a key step here is to switch x and y. We started off with, step 1 was to rewrite the problem with y instead of f of x. But then just to switch x and y. Nothing else moves. So this becomes x equals 2y minus 5. So switch x and y and then solve for y. So I'm going to add 5 to both sides. That gives me x plus 5 equals 2y. divide both sides by 2. So now y is by itself. So we get y equals x plus 5 over 2. And then the last step was to rewrite it with the new function notation, so the function inverse. So make sure you have the f negative 1 equals, right? And bring down your answer from above. So these generally should be pretty easy. You can do skip straight to step 2 if you want, if you're thinking, so this is going to become a y, and then the x and y are going to switch, so it's going to say x equals negative y plus 1. And solve for y, so I'm going to subtract 1, subtract 1. So x minus 1 equals negative y. Divide by negative 1, divide by negative 1. So y is going to be by itself now. So now I do x, oops. So now I do x divided by negative 1, which would be negative x. And then negative 1 divided by negative 1, which would be positive 1. And so then we put back in notation, f inverse of x equals negative x plus 1, which may seem crazy because it's the same thing we started with, but it turns out that function is its own inverse. Pretty weird. Oops, what's going on there? Alright, keep going there. So switch x and y, so x equals negative 1/2 y plus 1/2. Alright, so I want to get x by itself, so I'm going to subtract 1/2, or sorry, get y by itself, subtract 1/2. So that gives me x minus 1/2 equals negative 1/2 y. Then we need to get rid of that 1/2, so we say, oh, we divide by negative 1/2, but nope, we don't divide by fractions, we multiply by the reciprocals. So the reciprocal of negative 1/2 is negative 2 over 1, or really just negative 2. So multiply this side by 1/2, or about negative 2, and multiply this side by negative 2, but make sure we distribute over there. So on this side they cancel, so we're just left with y. And on this side we get negative 2x. Negative 2 times negative 1/2 is positive 1. Put the notation on f inverse of x equals negative 2x plus 1. And then last one of these, so x equals 3y minus 7. So start by adding 7, x plus 7 equals 3y, divide by 3, divide by 3. Y is by itself now, so y equals x plus 7 over 3. Finish it up with the notation f inverse x equals x plus 7 over 3. All done. Alright, so that's your inversing. Hopefully those are pretty simple. Alright, so graphing linear inequalities. So this is where we need to graph the line. We need to decide if it's going to be a solid line, a dashed line. So we tell the solid from the equals to's. So these here will all have solid lines, and then the ones that aren't equal to will all have dashed lines. Then we have to worry about shading. That'll come later. But generally, if it says y is greater than, that's a shading above. If it says, I don't have a specific example of it. Like if it said y is less than, it would be shading below. So what I want to look for is my y-intercept. Make sure that goes on the y-axis. And then my slope is negative 3 over 1, or 3 over negative 1. Can't have both negative. I'm going to go down 3, right 1, down 3, right 1. Or if I use the other slope, up 3, backwards 1. So just kind of double check yourself. Does that look like a negative line? Is it falling? said that was going to be a solid line, so use a straight edge. Just make sure you have a straight edge for the test. Put arrows. Okay, it says y is greater, so I would shade to the above that. So I'm going to do it lightly just in case you make a mistake and you realize that it's not really difficult to erase that. And you will be asked to pick a point within that shaded region. I know it doesn't say it here, but you would just pick, any point and you want within that shaded region. So here would be like, 3, 5. That would be an answer. Or you could always plug that back in to check to see if it worked. Like 5 is greater than or equal to -3 times 3 plus 4, which would be -9 plus 4. So 5 is greater than or equal to -5, which works. We can see that our point actually does work. The next one, y-intercept is -5. Slope is 1/3. So rise 1, run 3, rise 1, run 3, rise 1, run 3. Or I can fall, go back, fall, go back, fall, go back. But I still have a positive slope here. This is a not equals to, so this is a dashed line. Arrows, and then it says y is greater, so again I would shade above. Oops. So this region, and pick any point I want, so like 0, 0 could be a solution to this. X is -2, so remember x lines are vertical lines, so I'm looking at these points here. This is a not equals to, so I'd be looking at a dash line. So arrow, arrow. Okay. And it says x is less than -2. So what's a number that's less than -2? Like -5 or -4. Right, so all of these things over here have x values that are less than -2. So this would be your shaded region here. If we had to pick a point, something like that would work, like -6, 2. All right, the x value is less than 2, or x -2. Sorry. Okay, so then y is greater than or equal to 7. So remember, y lines are horizontal lines, so I would draw a horizontal line through y equals 7. And that is a solid line since it's equals to. And arrows. It says y is greater than 7, so that would get shaded above the line. Okay, so then this next one, I want to go ahead and get it into slope-intercept form. So I'm going to solve that equation for y. So the first thing I'm going to do is add 7x to both sides. So it's going to give me -2y is greater than 7x plus 14. Then I'm going to go ahead and divide by -2. Make sure I divide everything by -2. So here's one of the big things. Remember, when you divide by a negative, the inequality symbol flips around. So make sure that happens. It's something that's really easy to forget, so watch out for that. And then, so we have 7 divided by -2, so I'm just going to write that as a fraction since it's not reducible. So -7/2x, and 14 divided by -2 is -7. So there's my equation 2 graph. So my y-intercept is -7 down here, and then the slope is -7/2, which means down 7, right 2. So as I try to go down 7, I can't do that. I don't have enough space. So I could flip that and say, well, that's positive 7 over negative 2, which means go up 7 and then left 2. So there's my first point. If I go up 7 again and then left 2 again, get another point here. And then this would be a dashed line through those points. Arrows on the ends. And then reading my inequality, y is less than 7 means I want to shade below the line. It's in this space. Okay. And the last one, I'm going to do the same thing. I'm going to get y by itself. So first one I want to do is add 3x to both sides, plus 3x. That's going to give me 4y is less than or equal to 3x plus 12. Go and divide everything by 4. So it gives me y is less than or equal to, since I divided by positive 4, I don't need to switch the symbol. I get 3/4, not reducible, x, and then 12 divided by 4 is 3. So that would be here for my y-intercept. Rise 3, run 4. Have a point there, rise 3, run 4. Or I could go backward, or down 3, run backwards 4, down 3, run backwards 4. And then this would be a solid line because it's equal to. And arrows. And then this says y is less than. So I'm going to shade below the line. Okay. All right, so that's doing the inequality graphing. There will be another video for the other half of the review. Hopefully this is helpful.